Hey, good morning, everyone. Am I audible?
Good morning, sir.
Hey, good
Yes,
morning,
sir.
everyone. Okay, so this is going to be the continuation of yesterday's class, the decorators, right? So there is a one last topic which is pending, that is decorator chaining. Okay, so as part of yesterday's session, we discussed what is decorator and how you can implement the decorators, right? So adding additional functionality to the existing function is called decorator, right? How are you going to create a decorator? So we have a syntax, which is this is a decorator takes a function as an input argument and it just wraps the functionality. This wrapper, it takes some arguments, args and quarks. So this is the basic syntax of decorating, creating a decorator. And you're going to return the function. This for that function, you apply. Always remember a decorator takes a function as an input of. Here it is always a function. In normal cases, what you do, you take any value and you pass that function as an argument, right? When we discussed functions, we have four type of arguments. And most of the arguments, those are the values or data types. But this is the only case you pass a decorator. This is the only time you pass for a decorator a function as an argument. You are passing a function as an input argument. So that is a decorator. So all these topics we discussed, right? Once you create a decorator, you use @ to apply this decorator functionality to any way existing function, right? So now today's topic, we're going to discuss about chaining, decorator chaining. When I'm having a multiple decorators, when I'm having multiple decorators and all these to be applied to a single function, that is decorator chain. Okay, so I'm having a simple greet function. Okay, so this greet function, it says what? It is going to return some hello. Okay, so here I need two decorators. So here it has to be applied decorator 1. So here I'm going to apply one more decorator 2. Okay, when a function is assigned with multiple decorators, that is called decorator chain. So as part of decorator chaining, all you have to understand is execution flow, which is getting executed first and which is getting executed later. See, in a generic term, in a generic case, right? When I'm having only a decorator, okay, and I'm having a single decorator, what happens? The control comes to your function. Since your function is assigned with a decorator, the decorator will get executed first, right? Decorator gets executed first. Later, then your function gets executed. This gets second priority. Always remember, your decorator gets high priority. Then your function will come. Okay. I have shown you many examples as part of yesterday's discussion. So here what I am going to do is the same thing as part of decorator chaining. I'll be creating a multiple decorators and I'm assigning to a single function. How you will do this? Okay. So let's have a def of decorator 1. This is my decorator 1. A function as an input argument. Okay. And this is def of wrapper. If your function is not taking any arguments, you don't have to pass any arguments here. And also remember that. For example, what I'm doing is, let's take the same thing. Okay, so here I'm having this grid function, right? Grid function does not take any argument. Grid function does not take any input arguments. Okay, for this, I don't need to pass any arguments also here. Okay, so just calling it out. But this function, just call it. And if it is returning anything, since this is returning hello, right? You just do return. That's it. And finally, you return the wrap. Print. So to understand execution flow, right? Print. I am decorator 1. Copy this. Paste this out. So this is going to be my decorator 2. This is going to be my decorator 2. Okay. So what I'll be doing now is I'll apply both the decorators to my function. This is a single function. This is a single decorator function. Sorry. This is a single function and I'm applying this decorator. Okay. Let's create one more decorator to it. Sir, is it possible to have a multiple decorators to a single function? Yes, it is possible. You can create any number of decorators. Okay, but in a real time, mostly you will see 2 or 3 for a single function. Maximum 2 or 3. Okay, so when you are having a multiple decorators and you can apply these 2 decorators to a single function in this way. Okay, so now let's execute this. This got executed on this one. Let's execute this. So now I'm going to call this this generic function. See the execution. See the execution. As part of decorator chaining, when you are having a multiple decorators to a single function, when you are having a multiple decorators to a single function, it is going with top to bottom approach. Top to bottom approach. So here I'm having a grid function which is having decorator 2 and decorator 1. Now what is happening is it is going to execute the decorator 2 first. It is going to execute decorator 2 first, then the control is coming to decorator 1. Okay, so this is the execution flow is happening. So which one is getting executed is first. That is important as part of decorator chaining. See here, up to step number 70, there is execution of the structure of decorators only happens. Yeah. So when you are calling a function, from your calling a function onwards, the actual execution flow will start. From when you are calling a function onwards, the actual execution of the function will get executed. In even a real time, the same thing happens. Let's click on next. See here, since your decorator 2, it's like going from top to bottom approach. In the top to bottom approach, your decorator 2 is top, so it is going and printing your decorator 2. Decorator 2 will get printed first. Okay. Then we are calling the function. See here, but before even going to function, the control automatically going where? To function decorator 1 again. See here, since your decorator 2 is first, it is executing the decorator 2. Okay. Even before calling to the function, since you are having another decorator 1, right? It is going and executing the decorator 1. See here, it is going and executing your decorator 1. Got it? Now later, since I don't have any other decorators, it will go with actual function execution. So the control will come to line number 17. See here, the control came to line number 17. Okay, so that is all. When you're having a multiple decorators to a single function, it is going with the top to bottom approach. Your topmost decorator, decorator 2 is getting executed first, then later your decorator 1, and then as final, your actual function is getting executed. Okay, so let's change the order now. Let's change the order. So here, since decorator 2 is top, right? So that is the reason decorator 2 is getting executed first. Now I'm changing the order. Now this is decorator 1, and this is going to be your decorator 2. Now which one should execute first? Decorator 1 should execute first, then decorator 2, then your hello. Let's just print this out. Print hello. See here. Okay. So decorator 1 is there, right? It is there. It is the first one. It is going and printing the decorator 1. See here. Earlier it was decorator 2. Okay. So now it is printing decorator 1. Got it? So you are coming to decorator 2 now. Next, I am decorator 2. Okay. So finally, you'll get the result of execution of the actual function execution. Just print that hello. Okay. You just print it hello. Okay. So let's add this example also. When you change the order, change of decorator order, what happens? The execution also changes. So it will print decorator 1, 2, then hello. Okay. So next topic, we'll move on to generators. The next topic, we'll move on to the generators. We'll pause a minute. If you have any doubts, feel free to ask any questions. I'll pause for a minute. Okay. So if there is no questions, I'll be moving on to the next topic, which is generators. So what is generators? What is generator is? Generators are a function which is responsible, to generate a sequence of numbers. Normally, if you observe, there is a range function is there. We have a range function. We are generating a sequence of numbers. Okay. And generators will also plays the same role, but it is a different approach. Okay. It has some more features compared with the range function. Decorators means you are taking a function as an input argument, adding additional functionality to it. That is a decorator. Generators are where you are generating a sequence of numbers. How are you going to generate a sequence of numbers? How you're going to generate a sequence of number? We're going to use keyword yield. We're going to use keyword yield. Okay. So let me give you a quick example so you can understand. Def of, this is my generator 1. This is my generator 1. Which keyword you use to generate values? Yield keyword. Yield. Okay. Yielding 1, yield 2, yield 3. I am yielding the 3 values. So when I call this generator function, when I'm calling this generator function, I'll be getting these 3 values. These 3 values will be stored in a generator or object. When I call this generator 1 function, these 3 values will be returned. These 3 values will be returned as a generator object. See here, I executed it and I'm calling my generator 1 function. I'm calling my generator 1 function. See here, you'll get your generator object. You're getting what? Your generator object. Okay, sir, I don't want a generator object. I want to see what is the output this generator values is having it. Then all you have to do is you have to iterate it for I in for generator 1. Okay, print the I. The only way you can see is either you have to do iteration or either you have to do another type conversion. Okay, just like we discussed, right, in the map object and filter object, you have to do type conversion to list and tuple. Otherwise, you'll get a map object or a filter object. You are doing a type conversion there. Like the same wise, a generator object is there, and if you want to see the result, then you have to do type conversion or either you have to iterate the result. Okay, so in a function, see if you observe carefully, in a function, we are having multiple yield statements. Multiple yield statement. Yes, is it possible to have it? Yes, it is possible to have it. But in a function, if you are having multiple return statements, that is not possible. Only the first return statement will be taken considered. Okay, so def of add, okay. Return 5, return 6. Okay, I'm executing this. I didn't get any errors. See here, if I call this, what it will be written. Okay, first it will go and return the 5. The control never comes to return 6 because after your return, that will be your last statement in the function. Even you are having 100 lines also, that the remaining lines will not be taken considered. Okay, but in the case of yield, in your function, you can have multiple yield statements. No problem. But here, all these values will be added to a sequence. Correct? But in a generator, no need not only 1 to 3s, not only 1 to 3s. You can also generate anything. Here, you can generate anything. In the case of range function, you are generating only numbers, right? Here, you are generating a sequence of numbers. That is up to you how you're going to generate it. Okay, so for example, I'm changing to alphabets. This is going to be my C. This is going to be B. This is going to be A. And generate it. Okay, done. Just generator 1. Once you print the generator 1, you will get only generator object, right? What you have to do? You have to iterate them. You have to iterate them. For I in generator 1, print the I. Got it? Not only a numbers, you can also generate a different data type also. The one which is you are yielding in your generator function. That's what I told you. Generator is a function. Generator is a function which is responsible to generate some sequence. And how are you going to generate it? You're going to use a yield keyword. Can a generator function can have multiple yield statements? Yes, it is possible. If you are seeing any yield keyword in your function, just consider that as a generator. Consider that as a generator. Okay. Let me give you another way to access these generator values. For example, what I'm doing, I'm having G is equal to generator 1. I'm executing this generator 1 object. Generator 1 object, I'm assigning to a variable G. I'm assigning to a variable G. Okay. You want to access the value of your generators. Either you have to iterate them. Either you have to iterate them. Or either there is another alternative. So you have to use next. You have to use next. Okay. Pass G. What is the first value? Yeah. You got it. What is the next value? Next value of G. When you pass the first next now, it will depend on the first value. Okay. But if you see the generator object, A is gone. A is gone. Now if you print the next G, you will get B. You'll get B. A is gone. When you are doing a next operation in generic sense, in a generic sense, what happens is when you iterate, a generator object, okay, it will perform pop. It will do pop operation. It removes and returns it. It removes and returns it. So that is the reason in terms of storages, it is very effective. It is very effective. When you are iterating this generator, first value will be removed and returned. Next value will be removed and returned. If I do this next of G, what is the last value? C. Good. C is got. Now A, B, C all is gone. So now my generator object is empty. Now my generator object is empty. Okay. So even though it is empty, you try to perform the next operation again. I'm telling you, after this operation, my generator is what? Become empty. An empty object, you try to perform next operation, you will get error. What type of error is? Stop iteration. Stop iteration error you will get. See here. Stop iteration. Because all the values of your generators you iterated. Now you are doing a pop operation on empty generator. It is giving you stop iteration. The same thing you do a list. On the list, you perform a pop operation. You will get error. The same thing when you are having this generator also. When you are using a next to iterate it. This is happens. Always remember. Anyway, I already iterated everything, right? I'm telling you my G object is nothing. So even though it is a generator object, all the values of your generator is iterated. Now you do a type conversion to a list. You'll get empty list. See here, you'll get empty list because all the values is gone. You could do a tuple. You will get empty tuple because all the values are gone. Okay. But if I create a generator object again, I'm calling a generator object again. Now my G is going to have all the values of generators. Now you do a type conversion. See here, got your ABC. Got it? But remember, you iterated all the values and done the type conversion here. Now, once you've done a type conversion, all your generator values gone. With this operation, all your generator values are gone. If you perform tuple operation later, see what happens. See, when you are doing this list operation, right? You are taking a pop operation every time I'm mentioning. When you are returning a values with a generator, it always perform pop operation. Okay. Once you take all the pop operation, you convert it into list. So that is fine. Once this is done, all the generator values are gone. See here, when you do the type conversion to a tuple, the values are empty. Always remember, only one time you can do iteration of generator. Only, it's a rule. It's a golden rule. What is the rule? You can perform iteration on generator object only one time. Only one time only you can perform iteration on your generator object. Only one time. If you try to perform more than once, you'll get a stop iteration. Okay. For example, okay, now My generator object tree is empty. If I'm performing the next operation on G, what you'll get? Stop iteration. Because all the values of my list is already gone. All values of my generator is already gone. So now you are doing iteration again on empty generator object. So you are getting stop iteration. When you get a stop iteration, when you are accessing on empty generator. When you're having an empty generator object, you are performing the next method, you'll definitely get stop iteration. Okay. Any doubts in this? Sir, I understand the generator concept. Okay. So what is generator? You are generating a sequence of numbers or sequence of data using a yield keyword. Okay. So what is the start? Let's summarize this all the points. What is the summary? So if you understand these 4 statements, we are good to go with the generators. This is all you need to know. Okay. Let me give you one final example where we can use the generators. One very small example. Okay. What I'm doing is without generators and with the generators. Okay. If you see this difference, you'll understand where we're going to use the generators. Okay. I'm creating my list, number list. I'm using a list comprehension to generate this data. Okay. For example, for loop, I in range, some big number. And store that number. Okay. See what happens. See, it is getting executed. See how much time it will take. And finally, we'll get a memory error. Because this much number, it is storing into a list. It is definitely going to take a lot of time. See, running, let it run. And finally, you'll get memory error. See here, my session is crashed. My session itself crashed because it is a memory error. Okay, if you would have done the same thing in your IDLE or in your Visual Studio Code, you could have seen the error. But here, definitely got failed. Okay, but if I do the same thing in a generator, how you will do it? You just have to make it parenthesis. Okay, you just do parenthesis and run this. See how much time it took. How much time it took? It is just fractions of seconds. And if you want to access the first number, right? How are you going to do it? Use next function. Nums underscore list. You get 0. And you do next iteration. You do perform next. Again, you'll get 1. Every time it performs what? Pop operation. It removes and returns it. Okay. Any doubts in this? Memory storage. Just now you are saying this, right? Memory storage. Even you can store a bigger numbers in a simplest way. Okay. So memory storage is very good in generators. Okay. Performance. Good. In generators. Compare with list or tuple. Can compare with any of these. Always generator will take a very faster way to achieve this. Okay. If you want to check the thing, you can use the timer decorator. While you're performing generator option, and when you're performing any list or tuple operations, You can see that which one is taking very faster. Just use that timer. Okay, so that is all for today's discussion. We discussed two main topics. One is decorator chaining, another is generator. Okay, and I posted a link the chat. Just go through that. That is relevant to your database setup for the upcoming classes. Okay, so whether you can install your MySQL or Postgres, anything is up to you. But we will be doing the queries execution in database with the Postgres. Okay, I've shared you the installation steps. That video is available in the YouTube, so where you can follow those steps and do the installation.